Okay, so Scatterplots is one of our easier units in this class. The most challenging thing about Scatterplots, though, is that there are a lot of phrases that you need to memorize because the AP board expects you to answer questions about association very specifically. So we have on our next note sheet, there's a little box that says phrases to memorize. It's on the very last page, or no, it's on page 403. You're going to have a lot of these phrases to memorize by the end of this unit, and I'll put them all together on one piece of paper for you so that you know. This, like I said, is going to be one of the most challenging parts about this unit. If you're not a memorizer, that's going to be difficult for you. Okay, so hopefully when I mentioned association just now, I said the AP board expects you to describe association in a very specific way. That word association is ringing some bells in your memory. So starting at the top, investigating, that first blank is relationships. Investigating relationships between variables is central to what we do in statistics. So investigating relationships is central to what we do. When we understand the relationship between two variables, we can use the value of one variable to help us make predictions about the other variable. This is the first time that we're talking about being able to predict a value or predict an outcome based on a relationship that we know. However, this is not the first time we've investigated a relationship between two variables. This is the first time that we are investigating a relationship between two quantitative variables. That's what is new in this unit. We are investigating relationships between two quantitative variables. We already know how to determine if there is a relationship between two categorical variables. We know this by looking at two-way tables. So that first blank is two-way tables. Conditional distributions. And bar graphs. You had a question in the review for units 1 and 2 that reminded you of this process. The one that I remember the most is the male and the female and the SUVs and the sports car. So when you look at the relationship between variables or the association between variables, there's always an explanatory variable and a response variable. So I'm just going to highlight that. So we think that car weight helps explain, sorry, I'm just looking for the color pen I want. We think car weight helps explain, I don't want that, helps explain accident deaths. So we think the weight of a car helps explain accident deaths, and that smoking influences or affects, with an A, life expectancy. in these relationships, the two variables play different roles. So accident death rate, and life expectancy are the response variables of interest. So these are the outcomes we are measuring. Car weight and number of cigarettes smoked are the explanatory variables. So these may help explain or predict changes in a response variable. So down below, let's talk about why car weight would have an effect on accident deaths. Well, if you're getting hit by a little Geo Metro, that's probably going to do a lot less damage than if you're getting hit by a Dodge Ram. Would you guys agree? Especially in another car. Like if you're just walking down the street and get hit, yeah, the truck's going to do some damage. But even in a car, if you get hit by a little car, that's going to do way less damage than if you get hit by a huge car. So here, the reason that this is the explanatory variable is because heavier cars can do more damage. Heavier cars can do more damage. For number of cigarettes and the effect that they have on life expectancy, what you're comparing is whether or not they smoke like 0 cigarettes, 0 versus like 5 a day versus packs a day. I'm sure that this one is a little bit more intuitive and that it is easy for you guys to understand that if you're smoking packs of cigarettes a day, that probably is going to have an effect on the health of your lungs. Does this make sense? Okay, so in your Can You Do, the first 2 questions that you have are exactly the same as example 1 and 2. They just are different scenarios. So example 1, to study the effect of alcohol on body temperature, researchers gave several different amounts of alcohol to mice. Then they measured the change in each mouse's body temperature 15 minutes later. Determine the explanatory and response variables and identify if each is categorical or quantitative. So this one luckily gives you one really good indication of which one of these is the response variable. And that is the sentence, measured the change in each mouse's body temperature. So remember up here under response variables, we have distinguished that response variables are the outcomes that we're measuring. Well, in this problem, they're very specifically telling us they're measuring the change in body temperature. So body temperature is your response variable. See, categorical or quantitative? Well, I'm not going to tell you, so thank you. Quantitative. Body temperature is measured in degrees Fahrenheit or degrees Celsius if you live anywhere else but here. Okay, that means amount of alcohol is your explanatory variable. So I guess they're thinking the more you drink, perhaps the warmer your body temperature becomes. Amount of alcohol is also going to be quantitative. Now remember, quantitative means it's described with a number that can be averaged. Categorical is words. Okay, example 2. A researcher believes that the origin of beans used to make a cup of coffee affects hyperactivity. He wants to compare coffee from 3 different regions, Africa, South America, and Mexico, determine the explanatory and response variables, and identify if each is categorical or quantitative. So you guys try this one. I'm going to freeze my doc viewer and write down my answer, and then I'm going to walk around the room to verify that you guys are writing something. If you're unsure, write it in pencil so that you can erase. But write something. You can talk to your neighbor if you need to. Okay, as I was walking around, most of you are right on track. Your explanatory variable is the origin of the beans, and that is categorical. I knew the explanatory variable because it says affects hyperactivity. Hyperactivity, though, I think the whether it's categorical, which type of data it is, it depends personally, is what I think. It's categorical if they use a scale like low, medium, high. And it's quantitative if they use like a scale from 1 to 10. Because they didn't give me how they measured it, I, just to be on the safe side, list both cases. I would not expect you to know to do that unless I told you. And I'm pretty sure on your can you do, you don't have to do that. It's clear if it's categorical or quantitative. So this is step number 1. Step number 1 is that you need to know what is your explanatory variable and what is your response variable. Because when you build your scatter plot, this unit, unit 4, is called Scatterplots. It is based off of which variable is explanatory and which one is response. So the most useful graph for displaying relationships between 2 quantitative variables is a scatter plot. This is, you do 2 plots this entire unit. One of them is a scatter plot and the other one is a residual plot. So there are only two kinds of graphs that you talk about in this entire unit. So to learn about a scatter plot, which most of you guys have probably seen in science or math at this point, we're just going to start by actually getting one and going through and labeling the important parts about it. So example one is that manatees are large, gentle, slow-moving creatures found along the coast of Florida. Many manatees are injured or killed by boats. The table below shows the data on the number of manatees killed by boats from 1977 to 2010. So this is all of the data that is being graphed down here in this scatter plot. So the first thing to highlight is that each individual in the data appears as a point on the graph. Each individual appears as a point on the graph. In this case, when they say individual, they mean year. So each year shows up as a single point in the graph. So just to use this one as an example, this is the year 1998, and it is the point 809,66. So I went through and did this. I do all the notes before I do them with you, and you can see on mine that in order to figure out what these points are, I actually had to write on the graph and figure out what they were, which we'll practice at a different point in these notes. But you can go through and figure out what each point is. So every single one of these up here is a point down here. I think, do I want to highlight that? Maybe I want to circle that year up here in the table. So up here, the year 1998 says there were 809 registered boats and 66 manatees. Is it died or, yeah, died. Okay, now let's investigate our axes. So right here in our bottom left, we can see that we don't need to start at 0. On a scatter plot, you do not need to start at 0. When we're talking about categorical data, it is important that we start at 0, but for a scatter plot, you very rarely start at 0. The other thing that we've mentioned quite a bit is that our axes need to be labeled. Our axes need to be labeled. And really, we should give this graph a title. So in order to do that, I'm going to put what is on the y-axis. So I'm going to say manatees killed by boats registered. Now, when we say by, we mean like in a mathematical sense, not literally by the boats registered. We mean like a 2x4. Or when we talk about a table, we say a table's a 5x3. We're talking about manatees killed by boats registered. We're just describing the two variables. We're not literally saying they were killed by the boats registered. I mean, some of them were, but that's not what we're saying. Are we okay on that? Are you sure? So if you need to, you might want to write a little note to yourself that this is the y-axis by the x-axis. And I did not write everything on the x-axis because that just seemed really extra. Manatees killed by boats registered in Florida by the thousands just seems like too much, too long of a heading. Okay, so on our x-axis, we have our explanatory variable. They recommend that you write that X really big to give yourself a little bit of a reminder. We have our explanatory variable. So x-axis is always explanatory variable, which means y-axis is always response variable. And that is consistent with what you are seeing in your science classes if you talk about data like this. And then lastly, before we talk about how to describe a scatter plot, I just want to go up to the table and highlight that these are written in order, just like a normal table in math is. Your first column is usually X and your second column is usually Y. That's the same here. So this first guy is your individual. We learned about that in our very first lesson. Boats is X, manatees is Y. So if you're unsure and they give you a table, I would fall back on this convention. Okay, so then there's only two things left to discuss in this lesson: how to describe a scatter plot and how to make a scatter plot. So over here on our right-hand side, I have given you examples of linear association. Make sure that you are clear that this is linear. When we look at scatter plots, we are looking for a linear relationship. So when we look at scatter plots, we want the pattern or the form of the scatter plot to be linear. So there are different examples of how you would describe these linear relationships. So this would be a strong, actually not strong, perfect. This is an exact straight line. This is a strong straight line. This is a weak straight line. It's easier to see in this bottom one if you draw in like a line. You can see that those are kind of moving in a line or gathered around a line. No linear association would be this guy down here, this yellow one. There's no apparent association, so there's no form. There's not a straight line, it's not curved, there's not any clusters. It literally is a random scatter plot. So then the last thing to discuss is how we know if it's a positive relationship or a negative relationship. So both of them depend on what happens as x increases. So both of them depend on what y is doing as x increases. So in all of the examples on the left that are positive, as x increases, so I'll draw this arrow on the top one, increases means it's going to the right. What is y doing? Going up or going down? Up. So as x increases, y increases. That's how you describe a positive relationship. And in all of these pictures, as you move right, you also move up. On the negative ones, though, and it's easier to draw this one across the top, as x increases, y now is decreasing. So as x increases, y decreases. It's important to make that distinction because when we fill out this last paragraph on this page, we have to use this phrasing as x increases, y increases. So we're looking for a linear relationship. The stronger, the better. So now our last step is describing the scatter plot, and everywhere you see this in our notes. Right here it says describe. Right here it says describe. On this page it's going to ask us to describe. We're going to use the format that's here. It's always the same. So we start with the strength. There is a strong. We would categorize this as strong. Positive. Linear association. So this is on a different page, but you have to tell them strength, direction, and form. So strong, positive, linear association between, and then I usually just write what is on the X and the Y. So this time I'm going to write that whole big old thing. Between boats registered in Florida and manatees killed. So if they give me a graph, I am just going to take exactly what they write on the X and the Y axis. I shortened it up here because for a title of a graph, you want it to be nice and succinct. You don't want it to be big old long thing. Then this is where your X increases, Y increases comes from. In general, as X, so that's boats registered. In general, as boats registered increases, manatees killed also increases. Which hopefully makes sense, is sad, but makes sense. The more boats you have in the water, the more opportunity it is for those manatees to get caught by one. So I just want to make sure that everybody knows where I'm getting this last sentence. So in general, as this is X increases, Y also increases. I'm getting that from right here in our notes. X increases, Y increases. So I'm taking the context of the problem and writing that in. Are you hanging in there? Hannah? Strength, direction. And that's on our next page. It's just not in the right order. Good question. Okay, one last thing that we have to highlight is whether or not there are unusual points in our scatter plot. If you take out these 4 points, our scatter plot makes, or I shouldn't say makes, it looks a lot more linear. So if you got rid of these 4 points right here, I would consider these 4 points to be unusual. Hopefully you can see that that takes our linear form. That makes it look really good, in my opinion. You add in those 4 and it's not as strong. But if you take them out, that's a nice linear form. So we have, I would say we have 4 unusual points right there. I'm not sure if they're outliers because they are close to the rest of the data. They just don't fit the form as well. So we say there appears to be 4 unusual points, and those are the years 2003, 2004, 2005, and 2007. How do I know that? I went in the table and actually found or estimated what those were. So that's why on my practice paper, you can see, or hopefully you can see, how many lines I had to draw to get those values. Wasn't very easy, but I did it. Any questions before we move on? Litzy. Say one more time. If y-axis is? I usually, on this one? Yes. I usually will write it that way. So she's asking on this title, you have freedom to label your graph whatever you want to. Like you could have even just labeled this manatees killed. But I like to do, and you'll see in examples from the AP board that they put what is on the y-axis by what is on the x-axis. Always in that order. You'll probably never get marked wrong for what you title your graph, though. As long as you write something there, you're probably fine. Yeah? No, so down here where it says there's a strong positive linear association between, I usually just go X, Y. I usually just go in the alphabetical order, but no, it does not matter which one you put first. But here it does. When you say in general, you want to go whatever's on the X increases and whatever's on the Y and whatever it does. Any other questions? Okay, so most of your can you do is this, just describing a scatter plot. You don't have to calculate anything. You just look at the scatter plot and decide what's its strength, direction, and form. So that is formalized on page 403, describing scatter plots. Sometimes you'll also hear this referred to as describing association. So if it says describe the association between the variables, they mean the same thing as what we're doing here. Okay, when you write this down in your response, you usually put strength first, then direction, then form. So there's three main forms or shapes you're going to see. So form is kind of a different way of saying shapes. There's linear, that's the one that we want. There is curved, which can also be referred to as non-linear. And then there's clusters, which could be linear, and I suppose could be curved. So what do I mean by that? Down here, you have a linear form with two clusters. So that's what these arrows mean. Now, when we say clusters, the points need to be close together. When we say clusters, the points truly need to be clustered together, meaning they are closer together. So down here on this one, I would not label this as two clusters, even though it's clear you have like a group of people here and a group of people here. I would not necessarily consider those clusters. To be a cluster, your points need to be close together, like these guys, like truly clustered. Is that making a little bit of sense? Yes? Okay. Then strength. The strength of a relationship is determined by how closely the points follow a clear form. Well, that should say strength. Hello. We're missing the word strength there. The strength of a relationship in a scatter plot is determined by how closely the points follow a clear form. So this is a curved form that is strong. I would categorize this guy as strong. But down here, is this curved relationship as strong? No. Because they are not as close to this line that I drew in as this one is. So I would say that this is moderately strong. This is strong. Moderately strong. Can you guys see the difference between the two? Was that a yes? Okay. Then lastly, direction. That's what we talked about on this page. So it's always positive or negative, and that always refers to, as x increases, what is y doing. So for most forms, you have a direction. This guy, you don't have a direction because you don't have a form. So for these ones, I thought that we could go through and just quickly label strength, direction form. So like on this guy, I would say that he is moderately, no, I would say he's weak. This guy is weak. What's his direction? Negative. What's his form? Linear. This blue, well, they're both blue. The first curved blue scatter plot, I would say, is strong. What direction do you think it is? Positive. I had to draw the picture on this one to know. I had a real tough time with this one because he's looking like he's going down here. But in general, as X increases, Y is also increasing. And then curved. Don't forget, sometimes they'll call that nonlinear. Do you guys want to try the other ones? Yes. At least fill in the things that you feel okay about. So if you're not sure if it's positive or strong or which direction it goes, at least write down what you do feel good about. Okay. Middle guy is strong. He is also positive. As X increases, in general, as X increases, Y also increases. Curved or nonlinear. The purple ones, I would say, are strong, positive, linear, 2 clusters. And then our last one, hopefully we're used to, is strong, positive, linear, with 1 outlier. In this case, you would not consider this red point to be close to the data. That is far enough away from the rest of the data that he is very likely an outlier. Yes, Carter?
So, like the fourth graph, how would you write out in a sentence that
There, I would say there's one down here. We'll do it right here. Is that okay? Okay. So these are your phrases to memorize when describing a scatter plot. And I've tried to, as best I can, give you an indication of what would change. So there is, and then you choose strong, moderately strong, weak, positive or negative, linear or curved association between your X value and your Y value. And then in general, as X increases, Y, and then increases or decreases. Now, if you have outliers or unusual points, you're going to add those into this framework, and that's what Carter's asking about. Well, when I have an outlier or when I have some clusters, how do I write that in? So let's investigate that on our scatter plot of the percent of students taking the SAT and the mean math score for, I believe these are states or schools. So the scatter plot shows the percent of high school graduates in each state who took the SAT and the state's mean SAT math score in a recent year. So describe the association between the percent of students taking the SAT and the mean math score on the SAT. So to know what our explanatory variable is, we can just look at the graph. So they're thinking that somehow the percent who take the SAT is going to indicate how well the students do on the math portion. So the response variable is the mean math score. And then as I have highlighted already, there's two distinct groups in this scatter plot. So this group here, we kind of have a split at 30%. So let's talk about what we're seeing here. If there is a lower percentage of kids, their scores are higher. So if there is a lower percentage of kids taking the ACT in your state, their math scores are usually higher. But if there is a high percentage, so over here, you got everybody taking the SAT pretty much, the math scores are lower, which I think does make a lot of sense. So if we look at the average, let's say, test score on the last math, so if you're in 11th grade, let's say you're in 11th grade, if we look at your average score on the last test you took in math, I bet you guys are at an average of 80 or 90. But if we look at the average overall for every 11th grade student, is that going to be at 80 or 90? No, that's going to be at like 60 or 70. Why? Because you guys typically are the cream of the crop. You're hard workers and you're bright. You're in an AP class because hopefully you're driven and you have goals and there's a reason. Not every student is the same as you guys. So this does make sense to me. If a littler group is taking it, they get high scores. If everybody's taking it, the scores are lower. Well, it turns out there's a reason why. These states here, these represent kids who have a specific college that they're going to that requires the SAT. So the states that have a small amount of students taking the SAT, these students are usually taking the SAT because they need to. These states are states that also accept the ACT. So they take the SAT, but it doesn't really count for anything because they know that their ACT score can get them into college. Is this making a little bit of sense? So these are kids that have to take the SAT to get where they're going. These are kids that it doesn't necessarily matter, is what your book says. And that would make sense to me. Okay, so now let's put it into this form, because you don't got to say all that when you describe it. We just have to make sure that we understand what's happening here. So this is moderately strong. What's his direction? Positive or negative? Negative. Curved. Association between percent taking SAT and mean math score. In general, as percent taking SAT increases, mean math score does what? Decreases. When I roughly circled this, I did good on the first one, but not on the other one. When I highlighted these two groups, notice that on this one, the first time I did it, I didn't include that guy. And that's just because I was doing a rough circle of the group and he didn't fit in. And same with this guy. If I would have been being more careful, that guy also would not have been included in those two ovals that I drew. So I'm going to write, I circled 2 unusual points in the plot. Those states may be outliers. And I did not give the points because I did not want to estimate the values. In our manatees problem, they gave me a table so I could give the exact values. But in this one, I just think that you shouldn't even spend the time to try to estimate what those numbers are. So if these are clusters, how would we fit this in? There is moderately strong curved association between percent taking. I think at the very end I would just say also there appears to be 2 distinct groups in the plot. I would add in here states with less than 30% tend to have higher scores. And states with more than 30% taking the SAT tend to have lower scores. And you could write that, let me write this in a different color. You could write that right after the last sentence. Does that help, Carter? Okay, last thing that we're doing is building a scatter plot. I'm probably going to need to make a quick video for you of this, and when I say quick, I mean quick, like 10 minutes. Okay, so nationally, high and middle income students tend to perform better on math exams than low income students. So there is a trend that can be seen when you're looking at national data. You can see that in these bar charts and this line graph, that students who have free and reduced lunch typically do a little bit worse on math tests than students who do not. So this is the bar graph. Notice that the difference isn't that big. This line graph is just showing you what that actual difference is. So notice it doesn't start at 0, and that's okay. They're just trying to show you what the gap is. So there's a gap each year, well, each 4 years, of about 20 points between the two different groups. What they're thinking is that attendance and income status affects whether or not you score well on your tests. So what they have decided to look at is a random sample of 11 students who took the end of year Algebra 1 assessment in Texas and how many days they attended this year. Now that I'm talking about this, why did they give us income data and not attendance data? I mean the other way around. Do you know what I'm saying? They're telling us. Maybe I'll go watch the video again. I will connect this the next time I see you, because they're related somehow, I just can't remember. So we're going to look at attendance. A random sample was taken, and their percent of school days attended and number of questions answered correctly on the Texas end of year Algebra 1 assessment were recorded. Make and describe the scatter plot of the data. Okay, so maybe I'll name it first. X, Y. Questions correct by percent attendance. That's the name of my scatter plot. And then leave a little space here so that you can name, scale, and label your axes. So I'm going to go here and here because I got to try to leave a little room for my description. So my x-axis is percent of school days attended. I took that from the prompt. Their percent of school days attended was recorded. My y-axis is going to be end of year no. Questions correct on end of year Algebra 1 assessment. Holy moly, could that name be longer? I did EOY for end of year. Then we got to look at our minimum and our maximum values to decide what we're going to scale our axes. So let's start with X. What's the lowest percent? 67. So I'm going to start at 65 on the X. What's our highest point or our highest percentage? 99. Ooh. So I'll try to get to 100. So based off of that, you should scale by 5s or 10s. I think I'll try to go by 5s. I might have to go a little farther. Oh, I made it. Cool. Okay, for our Y, what is the lowest number answered correctly? 31. So I'll start this guy on 30. How high do I gotta go? 51. So I'll try to get up to 55 and I'll go by 5s again. So I'm using the min and the max for each category to decide how to scale. Oh man, I definitely did not need as many of these tick marks. Okay, now when you plot your points, you're just going to do the best you can. Nobody expects it to be perfect, even the AP board. So our first point is at 95 and 45. So I'm just going to do the best that I can to get a point at 95% attendance and a 45 questions answered correctly. And then I usually put an X next to it so that I know that I graphed it. And then our next one is 89% attendance, 42. And this is where it gets a little bit harder. Does not need to be perfect. You just do the best you can. 67, 31. Okay, I'm going to come through in a second and see how you're doing. Okay, let's check in real quick so you're not rushing to clean up. Are you ready? Okay, here's what my scatter plot looks like. As long as ours look similar, you're fine. I will make a very short video for number 2, how to put it into your calculator. You don't have to draw the graph. That's why it's going to be a short video. You just plug it into your calculator and describe the scatter plot. On your can you do, wait to do page 406. So 406, it's the last page that I brought you just now. Wait to do this. Do not do this. Don't kill it, just wait to do it until you get your test back. Are you all okay? Okay. Okay.